Welcome to The Explainer, where we break down big ideas. And today, we're getting into something that's behind pretty much every economic choice you make, every single day. It's called elasticity.
All right, let's kick things off with a little puzzle. I'm sure you've been here before. The price of gas shoots up, you groan about it, but you still fill up the tank. But if the price of tomatoes suddenly goes through the roof, you're probably just going to grab cucumbers instead for that salad, right? So what's the economic secret behind these two completely different reactions?
So, how are we going to crack this puzzle? Well, here's our game plan for today. We'll start with our gas and tomato mystery, then I'll show you the secret tool economists use to measure our reactions. We'll explore the whole spectrum of this tool, see how businesses use it to make money, and finally, we'll put it all together to solve a real-life case of tomato trouble. Okay, section 1, the gas versus tomatoes puzzle. So let's just dive right into this whole tale of two prices. On the surface, why we react differently seems kind of obvious, right? But underneath that gut feeling, there's this really powerful economic principle that can measure and even predict how we'll act. And that brings us to our next part, the economist's secret tool. And what is that tool? Well, it's called elasticity. Think of it as the secret weapon for figuring out just how sensitive or, responsive we are as consumers when a price changes.
Okay, so here's the textbook definition. It might look a bit dry, but trust me, this idea is super powerful. The best way to think about elasticity is like a responsiveness meter. It tells us exactly how much our buying habits change when a price tag moves. And that little phrase, units free, that's the real magic here. It means we can compare apples and oranges, or, in our case, gallons of gas to pounds of tomatoes, directly, no problem.
So how do we actually get a reading on this responsiveness meter? It's way simpler than it looks. It's really just a ratio. You just take the percentage change in how much stuff you buy, and you divide it by the percentage change in the price. That's it. If you get a big number, it means you're super responsive. A small price change made you change your habits a lot. If the number's small, well, you weren't very responsive. That one number tells us the whole story.
All right, part 3, the elasticity spectrum. So, we've got this number from our little calculation, but what does it actually tell us? Well, it places our reaction somewhere on a spectrum, from totally unbothered to extremely sensitive. And to make this super clear, let's talk about something we all know and love. Pizza. All right, let's look at pizza. Scenario A. Demand is inelastic. So first up, imagine a town where people are just crazy about their pizza. They've got to have it, no matter the cost. We'd say their demand is inelastic. They're just not very responsive to price changes. And check out this chart. The price takes a nosedive. A massive 75% drop. That's a crazy sale. But then, look at the quantity bar right next to it. Sales only went up by 30%. The reaction from the buyers was way, way smaller than the price change. That right there is a textbook example of inelastic demand.
Okay, now for scenario B, where demand is elastic. Let's imagine a different town, one that's full of bargain-hunting pizza lovers. Their demand is elastic, which means they are super responsive to price.
And wow, look at the difference here. The price cut is way smaller this time, only 25%. But the reaction? It's huge. Sales rocket up by 70%. In this town, people are incredibly sensitive to the price. Their response is way bigger than the price change that caused it. That's elastic demand for you.
So this table here kind of lays out the whole shebang. If the number we calculate is less than 1, we say demand is inelastic. That's our gasoline example, right? If it's greater than 1, demand is elastic. Think big purchases like furniture, where you'll definitely wait for a sale. That's more like our tomatoes. And then you've got the crazy extremes. On one end, perfectly inelastic stuff like insulin, where price just doesn't change how much you buy. And on the other end, perfectly elastic things. The classic example is two identical soda machines right next to each other. If one jacks up the price by even a penny, guess what? All its customers just take one step to the side and buy from the other machine.
Moving on to section 4, the total revenue test. Because this stuff isn't just for economists in ivory towers, right? This is an absolutely vital tool for any business trying to set its prices. How do they figure out if cutting prices is going to help them or actually hurt their bottom line? Well, they use something called the total revenue test. It's a really simple way to see how price changes, customer reactions, and the total money coming in the door are all connected. And total revenue is just, the price of one thing times how many of them you sell. And the rules here are simple, but man, are they powerful for any business owner.
If your customers are really price sensitive, if demand is elastic, then cutting your price is a brilliant move. You'll bring in so many new customers that your total revenue actually goes up. But if your customers are going to buy your product pretty much no matter what, if demand is inelastic, a price cut is a disaster. You'll just be losing money on every single sale without getting enough new business, and your total revenue is going to tank.
Okay, time to expand our toolkit with some of Elasticity's other forms. Because so far, we've really only been talking about price. But the amazing thing about elasticity is that we can use this same core idea, this measuring of responsiveness, to understand how all sorts of other things affect our shopping habits. First up is something called cross-price elasticity. This basically asks, hey, how does the price of another product change what you buy? So think about burgers and pizza. If the price of burgers suddenly goes way up, what happens? You got it. More people buy pizza. They're substitutes, so we get a positive number. Now, what about things that go together, like pizza and soda? They're complements. So if the price of soda skyrockets, pizza sales might actually go down, and that gives us a negative number. Next up, we can measure how a change in our income affects our choices. This is called income elasticity. For most things, what economists call normal goods, when we get a raise, we buy more of them. Like going out for a nice dinner. That gives us a positive elasticity. But for some things, what we call inferior goods, the complete opposite happens. The classic example is instant noodles. As your income goes up, you probably buy less of them because you can afford other stuff. And that gives us a negative elasticity. And finally, let's just flip the coin for a second and look at the seller side of things. Elasticity of supply. This measures how responsive producers are to a price change. I mean, can they just whip up more of their product if the price suddenly goes up? Well, it depends. It's pretty easy to hire another pizza maker for a busy Friday night. That's an elastic supply. But it's pretty much impossible to build a new car factory overnight. That's a very inelastic supply. It all comes down to time and the resources you have. All right, our final section. Case study, tomato trouble. It's time to put all this newfound knowledge to the test. Let's go back to that original tomato puzzle and see exactly how elasticity explains a real-world price shock that happened back in 2010. So, back in the winter of 2010, something pretty bad happened to the Florida tomato crop. A really nasty cold snap created this perfect natural experiment in supply and demand. The main source for winter tomatoes for the whole country was suddenly seriously in trouble.
And the fallout was just staggering. Get this, 70% of the crop was just wiped out. And look at that price jump. A 25-pound box that cost $6.50 one year shot up to $30 the next. That is a nearly 400% increase. I mean, how on earth did the price spike that badly? Well, elasticity gives us the perfect answer. When economists looked at the data, they figured out that the demand for these winter tomatoes was inelastic. It had a value of about 0.8. Think about it. In the middle of winter, there just weren't a lot of good substitutes, so people had to keep buying them even as prices went up. But at the same time, the supply was super inelastic, only about 0.22. You can't just magically grow more tomatoes overnight, especially not after a killer frost. So you see, it wasn't just one thing. It was the perfect economic storm. You had buyers who couldn't easily find an alternative, and you had sellers who were physically unable to make more product. That powerful combination of inelastic demand and inelastic supply is what created that insane price explosion. And this isn't just about tomatoes, right? This is the hidden force that explains why you kind of just grit your teeth and buy that expensive gas, but you'll walk right past the overpriced avocados. Now that you get elasticity, you have this brand new lens to see the whole economic world. So my question for you is, what everyday price change are you going to see differently tomorrow?